Well, guys, here's example 3. Something happened with the audio recording, so I'm going over it again. I'm not going to rewrite everything. I'm just going to take you through it. And maybe what I'll do is I'll highlight with a smaller highlighter, thin, and just what it is I'm talking about. So y equals 1/2 x squared minus 7 is exactly the same format as one of these, but it's just that x is we're going x minus 0 or x plus 0. Makes no difference. Okay, so if we look at the a value, just like in example 1 and 2, we have a is greater than 0. That means it opens up. Our vertex, like example 1 here where we have the 3 and we had the 4, our vertex was 3, 4. In this case, our vertex is 0, negative 7. So we've got 0, negative 7 as our vertex. Just like before, the axis of symmetry passes through the x coordinate of the vertex, so our axis of symmetry is x equals 0. Our y-intercept we can find if we let x equal 0. So we go 0 plus 0 squared is 0, half of 0 is still 0, and 0 minus 7 gives us a y-intercept of negative 7. Our x-intercept takes a little bit more work. So let me see if I can erase some of these marks and I'll take you through it. Alright, so let's try that with the x-intercept here. So in order to find the x-intercept, we let y equal 0. If that's the case, then instead of y we have 0 here is equal to 1/2 x squared minus 7. Now the first thing we need to do whenever we solve for a variable is to get rid of anything that's added or subtracted to the term that contains the variable. So I need to get rid of that negative 7 by adding 7 to both sides. So if I add 7 here, add 7 here, I get 7 is equal to 1/2 x squared. The next step is to get rid of anything that's multiplying or dividing the variable in that term. So I need to get rid of the 1/2 by multiplying both sides by 2 and multiplying both sides by 2. There we go. So 2 times 7 is 14. The half is gone with the 2, and I'm left with 14 is equal to x squared. Now here's what might be new to some of you. In order to get x by itself, I need to get rid of this exponent of 2. To do that, we take the square root of both sides. Now, let me take you to this piece here for a second. If I took the square root of x squared, let me back up. If x squared is equal to 4, and we have this, in order to get the x by itself, we take the square root of both sides. But remember, we're looking for the number that is squared that gives us 4. Normally, people think of 2, but it's also true that negative 2 squared is equal to 4. So whenever we take the square root of both sides to get x by itself, we need to show the positive and the negative root. So that's what I did here. I took the square root of both sides, and that left me with positive and negative root 14 is equal to x. And if you plug in root 14, you get 3.74. That means x is equal to positive or negative 3.74. Those are our x-intercepts. Now, the domain. Like every parabola, the domain is all x's that belong to the set of real numbers. So that's pretty standard for any of the parabolas we're going to see. And the range, also fairly standard, all the y's such that y is greater than or equal to the y-coordinate of the vertex, negative 7. Greater than or equal to because it opens up. Now, the graphing portion of it. So we're looking at this stuff over here. I have the vertex at 0 and negative 7. I have my x-intercepts at negative root 14, 0, and positive root 14, 0. That's over here. And it's nice to have another couple of another couple of points. So I chose arbitrarily. Let's find out what happens when x is equal to 2. So remember, here was our function. So I had y equals 1/2 x squared minus 7. I replace the x with a 2, square it, that gives me 4. Half of 4 is 2, and 2 minus 7 gives me negative 5. So when x is 2, y is negative 5. And because of symmetry, it's also true that when x is negative 2, y equals negative 5. And with that, we're able to draw this red parabola. I'll just retrace it here, purple, and like this, and purple. So that was example 3. You may want to pause that and put that all together for yourself. The next thing we're going to do is take us through how we find the function from a graph. So if you want to pause, rewind, etc., great. I'll be starting again in a couple seconds. Okay, so now I'm going to take you through 6 steps that we can use to determine the function from a graph. First step is I want you to get used to writing this vertex form. So y equals a bracket x minus p squared plus q. The second thing that we do is we identify what the vertex is. And remember, and I write this down, vertex is in the form p comma q. My vertex is negative 2 comma negative 4. So in the third step, I put that p and the q into the equation. And I write y is equal to a. I don't know that piece yet. Y is equal to a, x minus negative 2, which is the same thing as saying x plus 2, squared minus 4. Fourth point, now I want to figure out what the a value is. So I pick any point on the parabola. I could pick here at 0 comma negative 2. It looks like I could pick this one at 2 comma 4. I could pick this one. I could pick this one. It doesn't matter. So I'm choosing to work with this guy here at 0 comma negative 2. I take those points and then step 5, I substitute those coordinates into the equation here in number 3. So I replace the y and the x with the 0 and the negative 2. So that looks like negative 2 goes in for y, 0 goes in for x, 0 plus 2 is 2, 2 squared is 4. So I've got negative 2 is equal to a times 4 minus 4. Like we did before, I need to get rid of the 4 first. I need to get rid of anything that's added or subtracted to the term with the a. So I add 4 to both sides. Negative 2 plus 4 is 2, and that's equal to a times 4. I divide both sides by 4, and I get a is equal to 2 over 4, which reduces to 1 over 2. So a is a half. So then finally I can go to step 6. Step 6 is, now I've got all the pieces. Y is equal to 1/2, bracket, x plus 2, close the bracket, squared, minus 4. So we have an example, and you can review this. You can rewind it and see it again, catch up on the notes. We have an example of how to find the function from a graph. And we have 3 examples of how to graph given vertex form, a modified vertex form without a q value, another vertex form without the p value, right, or a p value of 0, and you've got everything that you need. All right, good luck, hope this helps, and we'll see you tomorrow.